So given the system of equations, we need to solve them using matrices. So let's write down them in matrix form. So matrix A matrix A is a matrix of coefficients. In equation 1, coefficients are 1, 1, 1. In equation 2, coefficients are 2, 3, 2. And in equation 3, it's 3, negative 4, 1. Matrix B is a matrix of right side numbers. So here we have 3, 7, 4. And we know that A times X equals B. And we need to find X, which is matrix of solutions. And X equals X, Y, Z. Well, since A times X equals B, we know that X equals A inverse times B. So let's start by finding A inverse. It joins the identity matrix onto the right of the original matrix, so that we have A on the left side and the identity matrix on the right side. So we get A here and identity matrix here, 1, 0, 0, 1, 0, 1. Now we will apply some elementary row operations. Let's start by multiplying the first row by 2 and subtracting it from the second row. So R2 becomes R2 minus 2R1. So here we get, I'll move this a bit, like this. Here we get, the first row is the same, but in row 2 we have 0, 1, 0, negative 2, 1, 0, and row 3 is the same. Our next step is to multiply the first row by 3 and subtract it from the third row. So the third row becomes R3 minus 3 times R1. So our matrix will look like this. First two rows are the same. And for the third row, we have 0, negative 7, negative 2, negative 3, 0, 1. Our next step is to multiply second row by 1 and subtract it from the first row. So we subtract, instead of row 1, we will have row 1 minus row 2. So our matrix will look like this. Matrix will look like this. It's 1, 0, 1, 3, negative 1, 0, and the rest are the same. In our next step, we multiply second row by 2 and add it to the third row. So the third row becomes the third row plus 7R2. And our matrix is 0, 1, 0, 1, 3, negative 1, 0, 0, 1, 0, negative 2, 1, 0. And here we have 0, 0, negative 2, negative 17, 7, 1. Okay, in our next step, we divide the third row by negative 2. So R3 becomes R3, negative R3 over 2. So again, first two rows are the same. I'll just copy paste them. And row 3 becomes 0, 0, 1, 8.5, negative 3.5, negative 0.5. In the next step, we subtract the third row from the first row. So instead of the first row, we will get R1 minus R3. And here it's 1, 0, 0, negative 5.5, 2.5, 0.5, 0, 1, 0, negative 2, 1, 0, 0, 0, 1, 8.5, negative 3.5, negative 0.5. So this is our inverse matrix right here. So A inversed equals negative 5.5, 2.5, 0.5, negative 2, 1, 0, 8.5, negative 3.5, negative 0.5. So now in order to find x, we need to multiply it by matrix B. So x equals this matrix times this matrix So here we will get negative 5.5 times 3 plus 2.5 times 7 plus 0.5 times 4. Next row is negative 2 times 3 plus 1 times 7 plus 0. And the next row is 8.5 times 3 minus 3.5 times 7 minus 0.5 times 4. Now let's simplify it, and we got that x equals negative just 3, 1, negative 1. So we have found the solution matrix, so that means that x equals 3, y equals 1, and z equals negative 1.